Thank you for attending the cost risk reliability presentation and demo. Let's start with the problem. Industrial risk is invisible. Organizations cannot quantify equipment failure in risk dollars. Maintenance, reliability, and finance operate in separate data silos. And here are the burning questions. What will failures cost us next year? Which assets drive 80% of our risk? Where should we focus our maintenance to reduce costs? Existing systems capture data. They do not forecast it. Reliability tools produce curves. They do not produce financial decisions. Cost risk reliability bridges the gap between raw data and financial clarity. How much money will CaRR save us? The biggest benefit, it reduces cost surprises. CaRR shows your likely quantifiable costs for next year so you aren't blindsided. Eliminates the why did this cost us $300,000 we didn't plan for moments. Cuts wasteful maintenance spend. Highlights the small number of machines that cause most of the cost. Helps teams focus efforts where they'll save the most money. Prevents bad capital decisions. Shows the true cost of running a machine versus replacing it. Avoids spending hundreds of thousands on equipment that didn't need it. CaRR guides decisions that typically save companies hundreds of thousands to millions. How CaRR fits into your workflow. Use this inputs you already have. Recent events, downtime logs, repair costs, asset master, work orders from SAP Maximo, and your CMMS. How CaRR works with your team. Reliability gets clearer risk rankings. Maintenance sees what to fix first. Finance gets predictable budgets. Executives get a clean, simple risk picture. And planners get a forward look at the next 12 to 36 months. CaRR doesn't change your workflow. It makes it smarter, clearer, and financially grounded. What executive pain CaRR fixes? CaRR shows what next year is likely to cost, so budgets stop jumping. CaRR ranks equipment by financial impact, not guesswork. Instead of reacting to failures, teams get early warning of high-cost risks. CaRR tells you which machines are worth replacing and which aren't. CaRR becomes the one shared model for reliability, maintenance, and finance. CaRR reveals the financial cuts you can't see. It shows you where the bleeding starts and how to stop it. So let's go ahead and examine the folio menu. New folio, open folio, save folio as, close folio, and then recent files. We're going to go ahead and select Exxon Oil Refinery. And then let's go ahead and examine the hierarchy. Here you have the root, and these are branches, and these are leaves. These branches are also called portfolio, and then the oil refinery is a root. So this is the root, branches, and then this is the leaf at the bottom. In the leaves, you have events. And so for each event, this is the data that's going to be used to perform our quantification. So you have the date of the event, the downtime hours of the event, the production costs, parts costs, labor costs, your environmental costs, regulatory costs, safety costs, and then your total per event cost. Now, in a perfect case, a perfect world, it's optimal to have all of this data, but these fields are not required. So let's just say you have the parts cost but no labor costs. You can still upload or edit this data. So you can add, delete, or save. So if we wanted to modify the downtime hours to, let's just say 300, can do that. Go ahead and save that. The per event cost is updated. If we need to add, we could also do that. Now what we're going to do is, once we've added the events, you can see here there are events here for each leaf. So what we're going to do is we're going to run our quantification on the subunit, the code cutting and handling. So we're going to go to reports and analysis and click quantification. And then you can see these values are here on a per event average. And the analysis window is here. This important number here, 6.99, is the lambda, or the average unplanned events per year. So let's go ahead and run this simulation. And we want to, what's important to note is the per event cost here, and then the expected annual loss. And then you have your tail value at risk in 80 percentile, your tail value at risk in the 90 percentile. So in a typical year, costs are around $4.7 million, with an expected annual loss of 4.9. However, risk is driven by tail outcomes, not averages. At the 80% confidence level, the average cost in the worst 20% of the years, tail value at risk 80 percentile, represents the expected exposure during the adverse operating conditions. At more extreme conditions, tail value at risk 95 reflects the average cost in the worst 5% of years and defines the plant's severe but plausible loss exposure. These tail risk measures quantify financial exposure arising from uncertainty in both event frequency and event severity. So the question we need to ask when we get to this screen is this TVAR 80 or TVAR 95 acceptable? And if the answer is yes, if the organization says, hey, we're willing to accept this loss, we're okay with this, but if they decide that this is not acceptable, then we need to decide on how we mitigate this. How do we reduce this exposure, and by how much? But before we get to that mitigation, we need to determine which assets have the assets that we should focus on, the ones that we should give priority. Where should we invest our funds, our expense, or our capex to get that the exposure down? So looking at this frequency distribution, this is a theoretical distribution based on the average unplanned events per year. And you can see right here, the 6.99 is about right here. And we look at the severity cost distribution. This is based on the Monte Carlo analysis. So we're basically sampling frequencies from the frequency distribution to create the severity distribution here. So let's go ahead and increase this to 1 million, and you can see how the shape becomes a little bit more refined. It's still as asymmetric, right skewed. So this is a little bit more defined too. So let's go ahead and figure out, which assets we should prioritize. So now we have our distribution. Actually, what we're going to do is let's go ahead and run this same analysis on the oil refinery. And we can see what the severity distribution looks like. Let's go ahead and jack that up to 1 million. So now we have our frequency distribution and our severity distribution here. And you can see how this shape is a nice bell curve shape, nicely structured. So let's go ahead and put that on the side, and we'll come back to that. Now we have our quantification complete, and we've decided that this is unacceptable. So now let's figure out which assets we need to prioritize. So when this loads, the Monte Carlo simulation runs again. And so we're going to click on oil refinery, And now we can see in our oil refinery all of the assets, all of the leaves of the oil refinery. And you can see that the coke storage loadout has the highest expected annual loss. And this is where we're going to focus our effort. And you can see in the sulfur and environmental unit which assets have the highest priority in each one of these units. The hydrocracking unit, you can see which one has the highest priority in the hydrocracking unit. So that the HCU heater. So if you're a plant manager, you want to look at everything at the macro level. You can look at it at the oil refinery level. Or if you are the owner of the sulfur and environmental unit, you can look at, say, hey, your flare knockout drum is the highest priority. This is where we need to put our effort. So this helps, at the refinery level, plant manager level, it helps you define, what's important. But you can also look at it at the unit level. So let's go ahead and put that on the side. So we're going to go to mitigation now. Let's compute our tail drivers. And you can see that the coke storage and loadout is coming to the top of the refinery. And we've already verified that in the prioritization. So now that we've computed our tail drivers, let's look at the mitigation strategy that we can use. Now we've already pre-populated coke storage and loadout. We decided that, let's just say that in the coke storage and loadout, there's a particular pump that is failing every, 2.3 times a year. And the design and engineering team have determined what the root cause is, and they've determined that we could reduce those failures by 30%, that failure rate by 30%, and then the cost per event by 30%. But it's going to cost us $2.5 million. So when we run that what-if scenario, we've determined that the ROI for that is about 1. And what this means is that we've reduced our tail value at risk by $2.6 million, but it's going to cost us $2.5 million to invest, which is still good because you're reducing your tail value at risk by $2.6 million. So when we go back to, let's see, this is, so if you can see here, our original tail value at risk was 77.8. This is about 77.8 because these are different. The number of simulations are different here. We had 5,000. We have a million here. But you can see the tail value at risk 80 here is 7.7.8. This is 7.7.5, which is pretty close. But the point here is we want to show that we said that this tail value at risk 80 is unacceptable, and we needed to reduce this, and that's what we've done here. We've reduced this by $2.6 million. Now we can still further reduce this if we perform other mitigation strategies on other things. So let's go ahead and close this out, and let's assume that we found the root cause of this atmospheric gas oil pump issue, and we can reduce that failure by the failure rate by 15%, and reduce the impact by, let's just say, 10%. And it's going to cost us $50,000. So we run that what if, and then now we have an ROI based on that of 1.13. So now we're at $2.8 million that we've reduced it to. So going back to, if we look at the oil refinery again, so we went from 77.8, we reduced it by almost $3 million. So we can keep doing this, running mitigation strategy on multiple assets until we get to the point where our exposure is an acceptable level. And you can print this to PDF, so you can run the report, print the report out, and submit to your management as needed.